morning everyone. Today we're going to look at a little robot. It's a little project I found on Thingiverse. It's a little robot based on this Arduino Uno, which is a cheap little dev board, which if you don't already have one, you should get one. They're really fun to use. So it's based on 3D printed parts, so you do need a 3D printer, but all the files are free. And what I've done different from the original post is just the code that runs on the Arduino itself, because the code provided was a bit old. Well, it didn't work for me anyways, but I just wanted to show you what it is, and because it's a fun. So what you need is, I've already assembled the motors, which you can get through the links below. These are tiny DC motors which I've soldered to these wires and hot glued to the wheels to make the trains. I don't know what these are called in English. Anyway, you actually use the filament itself to join them together, which is quite ingenious, to be honest. So I've already assembled this. Now what we're going to do is just assemble the thing itself and see what it looks like. So this might be a moving forward, fast forward. Just before that, this is an old motor, DC motor shield, where it actually has servo motors. You can plug there. It actually can do as well stepper motors. But it's basically cloned from an Adafruit board somewhere, and they're quite cheap to find on eBay if you're willing to wait. So it just pops on the Arduino like this, and now you just need to slide this on there. But before that, we need to insert the 9-volt battery. So I'm actually not going to fast forward, but just show how to assemble it. So you just need to be careful, because that's what you must not do. So anyway, I'm going to plug this in there. Pop, let's say. Here we are. Keep these away from one another. Use these little pieces of plastics to hold the motors in place, and keep the battery from moving about. So you need to bend them, and they just slide. That's not a nice sound. Here we are. Second one. Put the wires through. Put it in there. That was the cat. Done. Alright, so the battery's not moving. These are there, so now you need to slide this on it. So you actually got, the designer was quite ingenious and put some sliders on this side, so you can actually just throw this through there like that. Put the wires on the side so they can reach on top, and before you close it, you use this little holder, which, using this bit, holds the ultrasonic sensor. So you just it's not the perfect fit. If you can hear the cat behind me, I'm sorry. Alright, and now this just slides on there. It's difficult with the camera in front of me. Hang on. Okay. In the middle. Well, it's not the best fit, but it works. Before we slide this in, we just need to plug the wires. I had taken pictures on what the wiring is, but they're on the phone I'm using to record. So let's say red is obviously here. Brown would be earth or ground. Got a white wire for one of them. And grey wire, I should choose better colours, but the colour doesn't matter, the copper conducts the electricity, doesn't it? So anyway, so this is in there, so now we can just slide this here. Oops. slide it properly. Here we are, fits, slide this in, and now all we need to do is screw in the wires. So okay, so now the second motor, which is going to be around here. Okay, so these are in. Now let's plug in the ultrasonic sensor is actually using the servo pinouts, because you've got ground, positive, and then the signal on the last two pins. These two pins are wired on this shield to the 10 and 9 pins, so just use these pins for the echo and the trigger. I can't remember which is which between the grey and the red, the white, sorry, but we can just switch if it doesn't work. Here we are. Okay, so that's wired in. So now if I wire up the battery, so the positive terminal is this one, and lastly the negative terminal. You need to know, however, that there's no on and off switch on it, so as soon as I plug it in, the program will run. That's why I'm moving it up. And here we go. So basically, the wires for the motors are backwards. Okay, so just fast forward me changing them. Okay, so the wires are switched for the motors. Now let's just see if I've plugged in the AR properly. What's going on? Something jammed. Okay, so if I put there, okay, so of course the ultrasonic sensor is plugged in backwards. Ooh, one of the pins wasn't plugged in properly. Alright. Okay, so if it comes forward, put my hand and it turns. Okay, let's scare the cat. Yeah. Probably as focus didn't show anything. Attack! Yeah. Okay, so back on the computer, you can see that the project is available on GitHub. So you got instructions on how to do the installation for the script and everything. This will be updated where the video will be added. So what you need to do is download or git clone, however you do it, so you can download the zip if you want, so you get these files. The Arduino code is within this subfolder, the SMARS-Robot Ultrasonic. Well, I should have started with this. So SMARS is an acronym for Screwless Modular Assemblable Robotic System. So yeah, putting robot is it doesn't matter. Anyway, so it is true, I've only included the ultrasonic adapter, which you saw on the robot itself. You could, from the creators page, download accessible. He calls them DLCs basically. So you can have something which uses infrared sensors or other stuff. Anyway, so to run everything, so you need to install the Arduino IDE from the Arduino's website, and the only library you need to install is the ultrasonic library, where the instructions are there. It's very simple and straightforward to do. Regarding the 3D printed parts, there are a couple, and they do take quite a while. Actually, I just have a 3D printed part just finished, so I'm going to turn off the printer. It should be a little bit calmer. Here we are. Do that later. So you got multiple parts. They do take quite a while, so they're on average between 3 and 6 hours to print. But you can do this on 2 to 3 days. They're quite easy to print. There's no weird stuff. And once they're printed, you can use the assembly document, which is provided by the creator himself. So not me. I can't remember his name. It's in the original README file. So he's basically put CAD drawings on how to assemble, what to print, and everything, which is quite nice, a bit IKEA-like. So once you've got everything printed, you just assemble them, and you can buy the electronic parts through these links or using the creator's website, so basically eBay or Amazon. We'll do the trick depending on how much you want to wait or pay. So here's the credits. So it's tristomietitoredeituit. Well, that's who created them. Let's just take a little look at the code. Because so it uses the Adafruit motor library, the old one, which works fine. It's very simple, so it's a great project to do with a kid, for instance, to teach him how to program it. So it's a bit of a dumb robot, basically. So you got the main loop here. What it does, it measures the distance in centimeters using the ultrasonic library to the nearest object. If it is under a given distance, which is defined up at the top, it turns around, or if it is above, because if the robot has moved on forwards, basically it moves forwards and then repeats. So the turnaround and move functions are basically the same. The only difference is for forwards, both motors going forwards. For turnaround, one is going forwards and the other one's going backwards. So it's going up to a given speed, which I need to update. It's going to be updated so you can reduce the speed, the maximum speed. Otherwise, with a brand new battery, the thing is going to shoot off. So, hang on, thank you. So, the options you can change, and they're going to be some new ones. You know what? I'm going to go to the. Here we are. So you got the minimum distance to the object, so I've put 15 centimeters. The delay between, well, basically this is the time it moves forwards for. So it's a bit less than a second. However, you need to understand that before moving forward, basically the motors are ramped up to the maximum speed. Then there is this delay, which is the time delay. Basically, this variable is put in the main loop, which is basically brought back to the function. So it only delays after bringing the motor up to speed, delays the time you've given, and then slows the motors down before releasing them. So you can move this and this. So basically this tells what distance the robot is going to travel. This is how much it's going to rotate. So it's quite empiric. You can't do proper measurements. It's just a little toy. This is a time between the loops. So the time it stops, then scans, then does the loop again. And this is the max speed, which how fast do you want the motors to ramp up, because if you put 255, which is the maximum value you can put in this integer, with a brand new battery, the thing is going to shoot up. However, when you program it and power the thing with a USB cable from your computer, the small current available is actually with 75 not going to move the motors. But so yeah, just these two things to consider. So once you got this, you only need to pop it to Arduino IDE and upload the scripts, and once you're done, the thing is going to start to move. And I think that's basically it. If you have any questions, do ask them in the comments below. Again, this project was made by this bloke, and so I just want to credit him at the end. And I think that's pretty much it. So I'll see you in the next video, which will be another little robot which I'm printing right now. I'm just waiting for a couple circuits from eBay, so it might take a while for them to arrive. But it's a little thing I found on Thingiverse, which is well, it looks quite cute, to be honest. So I'll see you later, and that's it. Cheerio.